Hello, students. Let me start with a curious question. If you drop different students into a swimming pool, who gets out first? The fastest swimmers, of course. Electrolysis is like that swimming pool, but instead of swimmers, we have ions, and not all of them reach the finish line at the electrodes at the same time. This preference is what we call selective discharge of ions. It means even though multiple ions are present, only some of them actually discharge at the electrodes depending on clear rules. At the cathode, cations fight for reduction, while at the anode, anions battle for oxidation. And trust me, it's not random chaos, there's a proper chemistry audition process deciding which ion gets the spotlight. Now, the first big rule is the position of the ion in the electrochemical series. Think of it like exam results. The topper in the series behaves differently than the one at the bottom. For cations, those lower in the series are discharged more readily. For example, copper 2 plus is reduced much more easily than hydrogen ions, and silver ions love to accept electrons faster than hydrogen. For anions, hydroxide ions are released more easily compared to sulfate ions. So the rule of thumb is simple. Ions lower in the electrochemical series win the race to the electrodes. A neat little chemistry shortcut to predict outcomes. Now imagine a noisy classroom. If one student shouts louder than the others, the teacher notices them first. The same goes with ions. Higher concentration means higher chance of discharge. Take dilute sodium chloride solution. It has sodium, chloride, hydrogen, and hydroxide ions. But here, hydrogen gets reduced and hydroxide gets oxidized, so you end up with hydrogen gas at the cathode and oxygen at the anode. But in concentrated sodium chloride, things flip. Now chloride ions flood the scene and they take over. So chlorine gas comes out at the anode instead of oxygen. The takeaway? When ions are uneven in numbers, the majority grabs the mic. Let's zoom in on dilute sodium chloride solution. In water, sodium chloride splits into sodium plus and chloride minus, while water itself provides hydrogen plus and hydroxide minus ions. At the cathode, hydrogen plus ions gain electrons and form hydrogen gas. 2H plus 2 electrons gives H2 gas. At the anode, hydroxide ions lose electrons to give water and oxygen. 4OH minus becomes 2 water plus oxygen plus 4 electrons. So the products are hydrogen at the cathode and oxygen at the anode. Notice that sodium ions are present, but they sit quietly. They don't get reduced because hydrogen is easier to discharge. Now let's heat things up with concentrated sodium chloride solution, also called brine. Here the chemistry shifts. Again we have sodium plus, chloride minus, hydrogen plus and hydroxide minus ions. But at high chloride concentration, chloride ions outcompete hydroxide ions at the anode. So at the cathode, hydrogen gas is still formed by the reduction of hydrogen plus. But at the anode, chloride ions discharge. Two chloride minus ions lose 2 electrons to form chlorine gas. So the products are hydrogen at the cathode and chlorine at the anode. This is exactly how chlorine gas and hydrogen are produced industrially from brine in the chlor-alkali process. Now comes another twist in the tale, the electrode itself. If the electrode is inert, like platinum or graphite, it doesn't take part in the reaction, just silently allows ions to discharge. But if the electrode is active, like copper or silver, it participates directly. Take copper sulfate solution with copper electrodes. At the anode, copper atoms dissolve into solution as copper 2 plus ions, while at the cathode, copper 2 plus ions are reduced to metallic copper. The net effect is copper dissolving from the anode and plating onto the cathode. The electrode material itself joins the game, not just the ions, so always check. Are the electrodes passive spectators or active players? Let's pull all the threads together. Selective discharge depends on three factors: the position of the ion in the electrochemical series, the concentration of ions in the electrolyte, and the nature of the electrode. In dilute sodium chloride, we get hydrogen and oxygen. In concentrated sodium chloride, we get hydrogen and chlorine. With active electrodes like copper, the electrode itself dissolves and redeposits. So, it's not guesswork. It's predictable once you know the rules. Remember this one liner: selective discharge makes electrolysis systematic, not random. I hope now you can confidently explain why different ions show up at different times. Chemistry is not just about equations, it's about logic, patterns, and a bit of storytelling at the molecular level. See you in the next session with more chemical adventures.